Public cloud. In the public cloud delivery mode, all the physical infrastructure are owned by the provider of the services, which were provided offsite over the internet hosted at cloud vendors' premises. Here the customer has no control and limited visibility over where the service is hosted, as all these massive hardware installations are distributed throughout the country or across the globe seamlessly. This massive size enables economies of scale that permit maximum scalability to meet varying requirements of different customers, and thus provides greatest level of efficiency, maximum reliability through shared resources, but with rider cost of added vulnerability. Private cloud. In case of private cloud mode, entire infrastructure is owned, managed and operated exclusively by the organization or by a third-party vendor, or both together, and is hosted on the organization premise using virtualization layer. It also facilitates flexibility, scalability, provisioning, automation and monitoring, and thus offers the greatest level of control, configurability support, high availability or fault-tolerant solutions, and advanced security, which is missing in public cloud. Basically, very concept of private clouds is driven by concerns around security and keeping assets within the firewall, which results it to significantly more expensive with typically modest economies of scale. Hybrid cloud. As name suggests, hybrid cloud includes a variety of product mix from both public and private cloud options sourced from multiple providers at added cost to keep track of multiple different security platforms by ensuring all aspects of business to communicate with each other seamlessly. In case of hybrid approach, operational flexibility, scalability, efficiency and security are properly balanced by hosting mission-critical applications and sensitive data protected on the private cloud, and generic application development, big data operations on non-sensitive data, and testing on the public cloud. Hybrid cloud thus leverage benefits of both public and private cloud by maintain balance between the efficiency, cost saving, security, privacy, and control. The combination of the different service and deployment models enables different business models with new business roles. A cloud service is likely to have many layers of abstraction that build on top of each other with defined roles and duties. Accessibilities of these predefined services to the end user depends on the different service model. Abstraction layers of standard cloud model is depicted in adjoining. Service providers may adapt and compose several services into one, which is then offered to the cloud customers. Abstraction layers of model cloud. Cloud computing has emerged as a major shift in how computing resources are deployed and consumed both by individuals and enterprises. Cloud computing is an approach that covers a wide spectrum of cloud tools and models. This technology has a lot of potential and promises its consumer an enhancement in agility, efficiency and profitability by offering software, platform, and infrastructure delivered as services at very negligible cost, by reducing upfront investment and ease of use, by providing most user and eco-friendly operations. Like other technology, cloud also offers many benefits which come with some rider costs associated with it. Cloud too has its weaknesses, and that is security. Essentially, security in the cloud environment does not differ from the one in the traditional computing model. In both cases, the major focus is on the issues of protecting data from theft, leakage or deletion. Unlike in traditional computing model, issue of security in the cloud is slightly different. When individual users or organizations move computer systems and data to the cloud, security responsibilities become shared between user and cloud service provider. When an increasing number of individual users and businesses are moving their precious data and entire IT infrastructures to the cloud, it is natural to start wondering how security and privacy are handled in the cloud. Due to its intrinsic nature, however, the cloud environment highly susceptible to security threats as compared to its counterpart, as data is stored with some third-party provider and accessed on the web, which increases the overall vulnerability and thus affects overall reliability. Moreover, as most of the precious data is transferred to the cloud, it is difficult to maintain its integrity, and thus overall data security is compromised. Furthermore, with the advancement of technology and passage of time, the entire cloud ecosystem has evolved, and instead of relying on single cloud provider for buying/renting a cloud service, individual user or business organizations having freedom and flexibility to exploring more options to select multiple service providers simultaneously for different needs from pool of different cloud service provider, and thus eventually leads to more diffuse, seamless integrations of multiple service providers termed as fog computing. To make things further complicated, Data and services may be replicated horizontally among these multiple service providers, and as a consequence, it is often extremely difficult to determine the physical location as to where the data is being stored or processed at any one time. All this constituted the obvious security implications, as data is transmitted and stored in different locations over the internet and shared among multiple service providers simultaneously. Such data is neither within the control of the individual/owner nor the individual service provider, specifically in fog environment, which is common nowadays. Apart from just data, virtualization and applications are equally important security issues in cloud computing. Thus, security has severe impact on the overall decision-making process as to whether an individual or organization will adopt for the cloud services or not. Though cloud services have ushered in a new age of transmitting and storing data, and cloud has its own beneficial power, but it is imperative to take focused security approach, reviews the changes needs to undertake before making decision to migrate to the cloud. Some of the key aspects of cloud security in nutshell are depicted in Aspects of Cloud Security. Cloud Security Simplified. Access Control. System Protection. Personal Security. Information Integrity. Cloud Security Management. Network Protection. Identity Management. Access Control. System Protection. Personal Security. Information Integrity. Cloud Security Management. Network Protection. Identity Management.